Okay, so today we're going to talk about linear programming, all right? And the Common Core standard is, ready? It's AREI 6, which is solve systems of linear inequalities with graphs. We'll write that down first. I'm going to write down A dash for algebra, reasoning, equations, and we're going to do part 6, which is solve systems of linear inequalities with graphs. All right, that's our Common Core standard. We're going to solve systems of linear inequalities with graphs. All right. Jillian, it's not Gillian. Jillian, that does sound like a girl's name. So Jillian is planting a green roof that will cover 600 square feet. She'll use two types of plants. So she went to the store and she found Blue Lagoon and Raspberry Red Sedum. Each blue sedum will cover 1.2 square feet and each red will cover 2 square feet. Each plant costs $2.50 and Jillian can spend no more than $1,000, okay? Create a feasible region to model this. So first of all, what we have to do is, as always, we've got to come up with two equations. Somehow two equations. And to get the two equations, we've got to figure out what the heck's going on. So it seems to me is we've got two things. We've got an area problem. We've got square feet, okay? So I see some square feet here and square feet here. So let's start with equation 1. But before we even start with the equation, let's get some variables. So I think we better let B, we'll just let B obviously be their blue flower. We'll just call it blue flower. Let R equal our red flower, okay? So instead of X and Y, let's use B and R, okay? Because it makes sense, right? We're talking about red flowers and blue flowers, right? Now, my first equation I have to come up with has to do with area. So let's figure out what an area equation happens to be. So what I have is we've got the blue flower will cover 1.2 square feet. So we're going to go 1.2 blue plus, because we're going to do blue and red, plus our 2 red, and can be less than or equal to 600, okay? Now she doesn't have to cover the whole roof. She can cover as much of it as she wants to, but she can't go over 600 because then she's off her roof, okay? She'll be putting plants off the side of the roof, all right? So she's going to take blue flowers and red flowers and cover her roof. Less than or equal to, because she doesn't have to cover the whole roof, but she could cover the entire thing, right? Second equation I think has to do with cost, doesn't it? So let's take a look here at the second equation. So the second equation has to do with cost. They're $2.50 a piece, and she's only got $1,000 to spend. So my second equation is going to be my cost equation. Let's see what I've got for a cost equation. So they're $2.50 a piece. So I'll have 2.50 B plus my 2.50 R has to be less than or equal to 1,000, okay? So what we want to do is find this. We're going to try and make a graph. And the graph we're going to find will show every possible way that we can put flowers on a roof. How many reds and how many blues. But every possibility. For instance, really simple, she could do 2 reds and 1 blue. Now that probably isn't going to collect a whole lot of carbon, but she could. That could be one of the things. She could do 20 and 20. Okay, again, probably not what she wants to do, but that's possible. So to graph this, we've got equation 1 and equation 2. And let's graph these, okay? So if we're going to graph these two equations, we're going to have to solve for y. That's the only way we can graph, right? We need to solve for y. So let's take a look at equation 1. My 1.2b plus my 2r is less than or equal to 600. And there is no y, but we'll solve for r, right? Solve for y, but y is really r in this case, right? So I've got my red and I've got my blue, okay? So if I'm going to solve for my r, I'm going to bring over my 1.2, so I'm going to subtract that, right? I'll go 2r is less than or equal to a negative 1.2b plus 600. Divide by 2, divide by 2, divide by 2. And what I'm going to get is r is less than or equal to, let's see, that is going to be a 0.6, negative 0.6 b plus 300, okay? Well, that's the same thing as 3/5. It's just going to make it easier to solve. I'm going to have r is less than or equal to negative 3/5 b plus 300. 0.6 is the same thing as 6/10, which reduced to 3/5, right? I like to have a fraction because when I start to graph this, I'm thinking slope. I'm thinking down 3/5, down 3/5. I don't like a decimal. It's a little harder to graph, right? All right, now I've got to go all the way up to 300 to graph this. So what I'm thinking is I might go and graph, let's see, by 50. So here's my 100, 200, 300, 400, 5, 600. And I'll do the same thing down here. I'll go for the blues, 100, 200. Here's my 300, 400, 500, 600. Okay, just so I can graph this because I have to start all the way up at 300, right? So I went by 50, so I've got 100, 200, 300, 400, 500, right? So I graph that. And of course to graph on the first one, and I'll graph the, I don't have a, well I do have red. I've got chalk. So I'm going to do I'll do my first graph, I'll do an orange. So you can see I'll do this one in orange. So I'll start up at 300, 100, 200, 300, right? And then if I go down 3 or 5, I'll go down 1, 2, 3, 1, 2, 3, 4, 5. Down 3 over 1, 2, 3, 4, 5. And I'm going to use a ruler. And I'm going to graph that in. All right. And two other constraints I didn't write, but I'll write that real quickly down. I'll write it up here. I know that I'm going to let blue be greater than or equal to 0, and I'm going to be red greater than or equal to 0. Okay, these are important because we can't have negative flowers, right? So I'm not going to shade over in this region here because that'd be negative flowers. So this makes sure that when I shade, I'm only shading in this region right here, okay? I don't shade any, negative plants don't make any sense. You can't have negative red flowers and negative blue flowers. So I make sure that I put in the two constraints. Blue flowers are positive, red flowers are positive. Okay, now let's graph the second one. So equation number 2, I've got my 2.5b plus my 2.5r is less than or equal to 1,000. I'm running out of room, but that's okay. I'll make it easy. I'll bring over this one here. I'll subtract it, and I'll have a 2.5r is less than or equal to a negative 2.5b plus 1,000, right? I'm just solving for r. Now if I divide by 2.5, divide by 2.5, divide by 2.5, I'll have r is less than or equal to a negative 1b plus 400, okay? So I just divide. I just didn't show the work because I'm running out of room. So I went divide by 2.5, divide by 2.5, divide by 2.5. I get r is less than or equal to 1, negative 1 plus 400. Okay, so we're going to graph that one. And I'll graph that one in green, okay? Graph that one in green. So I'll go up to 400, which is right there. I'm going to go down 1, over 1, down 1, over 1, down 1, over 1. So what really is important in these, and I'm going to say it, I'm going to circle it, what's super important, probably the most important thing in graphing, is to find the point that they intersect in, okay? Because that becomes one of these corner points, right? So you really want to try and find that point that it intersects in, okay? So graph that graph in green. Okay, got that. Less than I shoot below, 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 below. But what I get is one region in particular where they overlap. When they overlap, that's the region I want to shade the darkest. So I'm going to make all of this in here be my region where they overlap. Okay, that's my feasible region. Okay, there and there. Okay. All right. So, are you listening? every single point within this overlapping region. Listen, every single point in here are all the possibilities we can do it and not go over budget. Every single region here tells me these are the flowers I can plant, combination of flowers we can plant without going over budget. Does that make sense? So there's lots of things. We can even go 0, 0, right? And this point right here is 0, 0. If we plant no flowers, we're not going to go over budget. We won't capture any carbon, but we won't go over budget. Does that make sense? And every single one of these combinations are all the different flowers. So what we want to do, though, is maximize it, right? To maximize it, we want to find our corner points. So first of all, let's find our corner points. All right, so one corner point, which we'll never, hardly ever use, is 0, 0. 0, 0 is a corner point. We won't use it. I'm only going to talk about it once because it's ineffective. But it is a corner. If you plant 0 flowers, you'll be within budget. You won't get anything done if you plant 0 flowers, but you'll be within budget, okay? So what's another kind of corner point? Well, it looks like another kind of corner point is at 0, 300. We have another corner point here at, looks like 250, 150. Okay. And we have one more corner point at, I believe, 400, 0. So where are the corner points? I look at my shaded region, okay? And my overlapped, and it creates a little figure, and it's got a corner there, has a corner there, has a corner there, and of course it has the 0, 0, okay? Now, big deal. Well, this represents 0 blue, 0 red. This represents 0 blue, 300 red, 250 blue, 150 red, 400 blue, and no red, okay? What's the best combination? Well, it all depends on absorbing carbon, okay? So we get one more thing. We're going to get a new constraint, and we want to take a look at creating the objective function. So what do we got? We want to maximize carbon absorption, okay? So we use P as our objective function, P, okay? So start with P, and we're going to have 1.4 pounds per year for red, so we're going to go 1.4 R plus 2.5, oops, I got that backwards, blue is I'm sorry, blue, good thing I used a pen, I can change that. And I've got red is 2.2, so 2.1 for red. Okay, now that's my objective function. Okay, now what do you do with that? Okay, want me to say it again? I should be 2.1. I know I said it wrong. It's Monday for me. Okay, what do we do with this? We're going to pay attention. We're going to plug in our corner points, and one of these 4 corner points should be the best, which means that's our combination to plant plants. Okay, so how do we do that? We're going to plug in 0, 0. Well, not really, but I'll show it. So I'm going to go P of 0, 0. So I'm plugging in my corners. Plug in corner points. Okay? So I'm going to go P 1.4 times 0 plus 2.1 times 0 is 0. Okay, and again, we won't plug in 0, 0 ever again. I'm just going to do it once because it seems dumb to even do it, right? You don't plant any flowers, you don't absorb any carbon, right? But let's check out our others, okay? Let's do P of 0, 300, which would be a 1.4 times 0. I'm just plugging it into my function, plus 2.1 times 300. So what I did is I'm taking my corner points and plugging in 0 and 300. See it? What's that answer? Let's see, I got it written down here somewhere. That one's 630. That'd be 630 pounds of carbon dioxide, okay? Let's plug in our other point, which is our 250, 150, which is a 1.4 times 250 plus 2.1, yeah, 2.1 times my 150. So all I'm doing is plug it in, this number for B, this number for R, and if you use your calculator, which I already did, we're going to get an answer of 665. It's a little bit bigger, so that's a better combination. Okay, let's do the last one, Abby. P of 400, comma 0, which is going to be a 1.4 times 400, plus 2.1 times 0, and I get an answer of 560. Okay, so if her goal is to maximize the amount of carbon, which one's the best? She wants to maximize the carbon absorption. Which one's the best? Yeah, it's got to be this one, because that's the greatest number. So here's what we're going to plant. We are going to plant, here's our answer, 250 of the blue flowers and 150 of the red raspberry sedum, I don't know, anyway, flowers. So that's our answer for a total of, so we get a total of 665 pounds of CO2. Okay, that's how these need to be answered. Okay, now, let me go ahead and push stop.